If you recall from the lesson, we talked about how computers read everything in zeros and ones called binary. But on our computers, we don't enter zeros and ones every time we want to enter a letter, a number, or a symbol. So for instance, if we wanted to enter our name, so say my name is Tom, I would just push T, O, and M instead of putting out 8 zeros and ones. So how do we convert this by hand? If you recall that binary is done in the base of 2, so we have 2 to the 7th, 2 to the 6th, 2 to the 5th, all the way down to 2 to the 0. And so if you recall that there are 8 bits within a byte, so here's bit 1, 2, 3, 4, 5, 6, 7, 8. And then all these together make up 1 byte. So for T, we will have 8 zeros and ones that will make up the byte that represents T within binary. So now that we know the letters, well, let me jump back real quick. So 2 to the 7th, if we do 2 to the 7th on our calculator, we get 128, so that's where that number comes from. 2 to the 6th, that's 64. And then if we go all the way down to 2 to the 0, that's how we get 1. And so those numbers will come into play here shortly whenever we're trying to figure out how to get it from text to binary. So now that we know the letters that we want to look up, if we pull over the quick little chart that I have, so here you'll notice that there's a capital letter and a lowercase letter. In binary, they're represented differently, but for the purpose of this exercise, we're just going to assume that they're all done in capital letters. So T would be 84, O at 79, and then M at 77. And so those numbers are going to be how we figure out what the binary representation of each letter is. So let me jot those down real quick. So T was 84, O was 79, and then M is 77. And so now that we know these numbers, all we're going to do is simply take these numbers and try to add them up to get this number. So we always start with the biggest bit, and since 128 is bigger than 84, we can skip that. So we're just going to put a 0 in. A 0 just represents that we are skipping that bit. 64 goes into 84, so we're going to accept that one. Now 64 plus 32 is larger than 84, so we're going to omit that one as well. Now 64 and 16 gives us 80, which still falls within our 84, so we're going to accept that. Now 80 plus 8 is going to be larger than 84, so we're going to skip that one. 80 plus 4 gives us 84, so we'll accept that one. And now that we've reached 84, we can go ahead and omit the 2 and the 1. And so now we have a representation for each bit, and all together this represents 1 byte, which gives us the T in binary, which would be 0, 1, 0, 1, 0, 1, 0, 0. Okay, so moving on to O, again, we're assuming this is the capital O, and this is represented by 79. So 128 is way too big for 79, so we're going to omit that one. 64 will go into 79, so we'll accept that one. Now 64 plus 32, that's way larger than 79, so we're going to skip that one. And 64 plus 16, that's larger than 79, so we're going to omit that one as well. Now 64 plus 8, that falls within our 79, so we're going to accept that one. Let me pull up my calculator so I can show you guys where we're falling at in here. So 64 plus 8, let's try that again. 64 plus 8 gives us 72. So 72 is where we're at right now, and we're trying to get to 79. So 72 plus 4 is 76, so we can accept that one. 76 plus 2 is 78, so we can accept that one. And then 78 plus 1 is 9. So for the letter O, remember this capital O, all these bits represent the byte for it, so it would be 0, 1, 0, 0, 1, 1, 1, 1. And that represents the capital letter O in binary. Okay? And so for our final one is the letter M. And so this one's kind of easy to do because we can just go off kind of what we did for the letter O. Again, we know 128 is too large, 77, so that gives us 64. those two will be too big if they were too big for 79. Okay, and so 77, so here again, if we do 64 plus 8, because we want to make sure we don't go over, is 72. So we'll accept that one. 72. And then 72 plus 4 is 76. 76 plus 2 will be 78, so we don't want that one. And then 76 plus 1 will be 77. And so here we have the letter M as well. And so in binary, M will be represented by 0, 1, 0, 0, 1, 1, 0, 1. And so now we have representation for each letter of our name. Now binary is written out if we wanted to write it completely out end to end. So if we start with the letter T, we would start, oh, that was really bad, sorry guys. We would start with that, so it would be 0, 1, 0, 1, 0, oh man, 0, 1, 0, 0, followed by a period, and then we would move on to the letter O, and it would be 0, 1, 0, 0, 1, 1, 1, 1, period, and then followed by our letter M. 0, 1, 0, 0, 1, 1, 0, 1. And then this would be the name Tom written out in binary. As you can see, it's a good thing that we have the computers to do it for us manually, because if your name is really, really long, it would be a really, really long number. But this is how you convert letters from text to binary.